Domain and inequalities. So there's three domain restrictions overall. You need to know this does not include trigonometry. That's its own situation. So for domain, the first rule is a denominator. We know anything in the denominator cannot equal zero. So whatever's in the denominator, you said equal to zero, and that's what it cannot equal. Anything inside of a square root or an even root, square root, fourth root, sixth root, eighth root, okay, anything inside, okay, has got to be greater than or equal to zero. If you have a natural log or a logarithm, anything inside of there would be greater than zero. So you have denominators, square roots, and logarithms, and the restrictions that are associated with it. Again, for rule number one, we know we can't divide by zero. For rule number two, in a square root, it's got to be greater than or equal to zero. We're not taking the square root of negative numbers. We're not doing imaginary numbers. And logarithms, if you recall the graph of a logarithm, you can't have anything that's negative or zero for that matter, okay? So if you're asked to find the domain to kind of, use these rules, for this first one, you set the bottom not equal to zero. You say, okay, well, x minus 3 times x plus 3. You have to factor this. It's a difference of squares. So x cannot equal 3 or negative 3. They may ask you to write this in interval form. So that'd be negative infinity to negative 3 union negative 3 to 3. Let's make this screen a little wider. Union 3 to infinity. That's everything but negative 3 and 3. For a square root, you said whatever's inside of a square root greater than or equal to 0, and x is greater than or equal to negative 3. That would be negative 3 with a bracket because it's equal to, comma, infinity. Natural log of x minus 2, you set the inside just greater than 0, and you get x is greater than 2, meaning it's 2 with a parentheses to infinity. Pretty standard. Let's do another round. We have a denominator. So you set the denominator not equal to 0. So factor. So how do you factor this? Good answer. You don't. You can't factor a sum of squares. There's no rule for factoring a sum of squares. A difference of squares you can factor. That was over here. But a sum of squares you cannot factor. Even if you try to keep solving this, you subtract the 1 over, and we're not square rooting negative numbers. We're not doing imaginary numbers here. So what does that mean? There's no restriction. Think about it for a second. Take any number and square it and add 1. The bottom will never equal 0. So that's all real numbers, negative infinity to infinity. On the right here, we have a square root. Anything inside of a square root is greater than or equal to 0. But it's also in the denominator, which cannot equal 0. So it's greater than or equal to 0, but it's not equal to 0. So you conclude that it's just greater than 0. So that means x is greater than negative 5. Lastly, again, anything inside of a square root, you set greater than or equal to 0. Whenever you have more than just a linear factor, linear meaning like x plus 5 or x plus 3, this is rational. We have more than one x here. So if you have more than one x, you may have to set up a number line for an inequality. If you set each one of these equal to 0, you would have a negative 4 and positive 2. So you do number line, open or closed. Well, negative 4 is closed. Why is 2 open? Because it's also in the denominator. Be careful. Right or wrong answers can be the difference between a parentheses or a bracket. You've got to be careful. From here, you would pick test points, before and after, and plug into the inequality. So you pick points like before and after, figure out if what's going on in those intervals is positive or negative. So I'm just picking random points for each section. Plug in a 3 into here. 3 plus 4 is positive. 3 minus 2, just plug in x equals 3, okay? So 3 plus 4 is positive. 3 minus 2 is positive. Positive divided by positive is positive. Plug in a 0 for x. 0 plus 4 is positive. 0 minus 2 is negative. Positive over negative is negative. Plug in a negative 5. Negative 5 plus 4 is negative. Negative 5 minus 2 is negative. Negative over negative is positive. What did I want, though? I wanted everything that was greater than or equal to 0, meaning I wanted all the positive intervals here. So that would be negative infinity to negative 4 with a bracket, and 2 with a parentheses to infinity. And there you go with domain, your 3 rules, and dealing with inequalities, especially the case where you have a number line.